This is Viterbi Voices, your chance to hear stories about research, classes, student life, and more.
Directly from our students, faculty, and other members of our engineering community. All right here at the USC Viterbi School of Engineering.
Welcome back into Viterbi Voices. My name is Paul Ledesma. I'm the Director of Undergraduate Admission here at the Viterbi School of Engineering. This is a bonus episode. It's just me right now. I'm by myself. I'm in my house. Audrey is in Colorado. I wanted to get a quick bonus episode up for you because we are holding a number of virtual events for our newly admitted students. And the one we just held today was a virtual faculty roundtable with some faculty from the Sunny Estani Department of Civil and Environmental Engineering. And this faculty roundtable was about an hour long, and it was I was joined by the chair of the department, Dr. Lucio Soibelman, the director of the Environmental Engineering Department, Amy Childress, and one of the other Civil and Environmental Engineering faculties, Associate Professor Dr. Felipe de Barros. And Dr. de Barros and Dr. Soibelman and Dr. Childress joined me in a wide-ranging conversation about the disciplines of civil and environmental engineering. We talked about the curriculum, we talked about what it takes to be successful, and we took questions live from our audience of newly admitted civil and environmental engineering students. So I'm going to get out of the way, but I wanted to say hi real quick. I hope you're all doing well, and I hope that this is going to be passing sooner than later. If you're an admitted student and you're thinking about civil and environmental engineering, if you missed the session, I hope you're able to listen to this episode to get some feedback. And if you ever have any questions, you can always email us at vadmit@usc.edu or call us at 213-600-9919. That is our mobile number while we are away from campus and working remotely. But without further ado, let's get out of the way and give it off to Dr. Soibelman, Dr. Childress, and Dr. Felipe de Barros to talk about civil and environmental engineering. Okay, good afternoon. Welcome to everybody. It looks like everybody's kind of making their way in. We got most people with their cameras off. If you want to turn your camera on, that's fine too. We could see you. But welcome to the Viterbi School of Engineering, the Sunny Estani Department of Civil and Environmental Engineering Faculty Roundtable. My name is Paul Ledesma. I'm the Director of Undergraduate Admission here at the Viterbi School. It's a pleasure to bring to you a few of our faculty in the Civil and Environmental Engineering Department. And I'm going to let them introduce themselves. We'll start with the chair, Lucio Soibelman.
Hello, everyone. My name is Lucio Soibelman. I'm the professor and the chairman for the Civil Environmental Engineering Department. I do research with computing in civil engineering, so several AI and machine learning on civil engineering.
All right, great. And then Amy Childress.
Hi, I'm Amy Childress. I'm professor and director of environmental engineering at USC, and I do research in membrane processes for wastewater reclamation and desalination. And then I also direct the environmental engineering program where we look at air, water, energy, and how those all come together.
All right, thank you. And then Felipe de Barros.
Yes, so hello everyone. My name is Felipe de Barros, associate professor in civil and environmental engineering. I've been at USC for almost 7 years, a little bit over 7 years by now. Right, Lucio? I think so. And my research is in groundwater hydrology, and I study fate and transport of contaminants in groundwater flows and how that impacts human health.
Okay. Well, I think I'll start out with just some general questions and probably some more in-depth on introductions for the three of you. And then for all of our students that are out there, get your questions ready. Don't ask them yet, but I'm going to have you start to put questions in the chat momentarily. I'd like to start first with the chair, Dr. Soibelman. Would you mind giving just a general overview of kind of your view of civil and environmental engineering, the goals of the department, and how you believe the department is structured for our incoming students?
So our department, it's a pretty interesting department. We are very non-traditional in the way that we are organized by the problems that we want to solve. So we have a lot of very young faculty. We did a lot of hiring in the last 8-9 years. So you have a lot of energy from new faculty. Working in research, I know that for undergrad sometimes doesn't think that it's the most important thing, it's the research. But when we think about the cool research that the faculty is doing and they bring that energy to the classroom, makes it a very, very interesting place. So you have four main areas that you focus our research that is in extreme events, earthquakes, tsunamis, now understanding urban implications in the COVID-19. We are doing those types of research and earthquake engineering. And then we have the sustainability group that looks at air quality, pollution impact on health, global warming, energy, water systems, green buildings, smart buildings for energy efficiency and those types of things. We have a group in water that Amy already described. You have a lot of interesting research on filtration, desalination, membranes, water chemistry, microbiology, wastewater. So a lot of very, very interesting research going on. And then you have the group on systems of systems that it's really looking the interface of the traditional silos in civil engineering. What the example that I always use is that transportation engineers design the transportation network, water hydraulic engineers design the water distribution network, but when you have a water main break, you flood the highways and all the systems are connected. No one really understands those domino effects, and you're really trying to look into those interfaces. So we're a department that have a lot of ongoing research, young faculty, energy, and I think that this all spills into the undergrad with a new curriculum that we just developed, and it's been a very, very exciting place. Being a department in a private school, the classes are smaller, so those students really interact with the faculty in a way that it's very unique to USC.
And then as Director of Environmental Engineering in the department, is there anything you'd like to add on that or your perspectives as an environmental engineer?
Well, I think we have a great environmental engineering program. We have a lot of young faculty members who really engage with the students in their classes, the students in their labs. And as Lucio mentioned, we have small classes. And so I think the students feel like they get a lot of interaction with their professors. And we do like to have undergraduates do research in our labs. And the topic areas that our faculty study, things like urban heat islands and how to cool cities and how to bring renewables into the power grid and new water supplies. I think those are hot topics of interest to a lot of students.
Can you tell us a little bit more about urban heat islands?
Yeah, so the urban areas tend to get hotter. We have surfaces and roofs and tall buildings and not so many trees to cool things off. And so one of our faculty in particular, George Van Weiss, he studies white roofs or cool walls, the effect of trees and bringing in more evapotranspiration to cool off the urban areas. And some of his work even has gone to officials in the city of LA who have implemented it. So that's exciting when you do research in a lab or with your students, but it goes on to get activated in the public.
That's great. Thank you. And then Felipe, can you give us a little bit more information about the research? You mentioned it in your introduction, but the research that you do, and also if you wouldn't mind adding on to that, how that can translate to some of the classes that some of our undergraduates may find themselves in.
Of course. So just summarizing, my work is mainly on groundwater hydrology. So I actually study how the flow patterns of groundwater, in the subsurface environment. But mainly my focus is trying to understand how these patterns of flow, they impact dispersion or migration of contaminants. So you can imagine there are a lot of interesting aspects of this research. For example, we think about climate change, right, which is actually changing our recharging to aquifer. Now, luckily here in LA, about a week ago, or this week actually, we had some more rain, but this is not always the case. So every time you have like a rain event, for example, that can actually recharge aquifers and mobilize contaminant plumes. If the lack of rain can also lead to plumes which are immobile in the subsurface. So understanding the trade-off between these factors and transport of these contaminants is actually what I do, and how to translate that information into decision-making by linking metrics or scientific metrics or indicators to decision making, right? So risk managers, okay, so should a site be cleaned up? Shall we switch our water supply to a different source, for example? And of course, I bring all of these elements in class, right? So that's really important, because showing theory, but how that's actually applied is what triggers the interest in students, right? Because our goal is to produce engineers that can think critically about problems. So I always try to bring elements on the state of the art of my research and what's going on even in the department. You know, it's like, for example, oftentimes in my class, I always try to make a link with my work and what Amy Childress, Professor Childress, is actually doing, or what Professor Kelly Sanders is doing, where she works in the energy water sector, or try to link that to other research from other fellows in my other colleagues in my department.
Thank you. This is really for anyone or whoever wants to jump in, but can we help our students understand the approach to the undergraduate education, maybe how the degrees are structured, or what they'll find at least in their first year in taking civil or environmental engineering courses?
I can talk a little bit about that. In the first years, the students have within the department class on introduction to civil or either introduction to environmental engineering. So this is where we try to introduce them to the department and what's going on, and to the domain. The students take a School of Engineering wide class called Freshman Academy. So the interesting thing about USC is that we have a very large, and you are going to talk about this probably, very large retaining rate. So the students that start in engineering, they do graduate in engineering. That what USC does is that it's very easy to move from one major to another one within engineering. So one way that the school does this is that Freshman Academy, where the students in civil are introduced to what is happening in the other departments within Viterbi. So the curriculum is very similar at the first year, the freshman year, for all engineering students, allowing them, if they realize that they thought that civil engineering is something, and then when they arrive, they realize, oh, it's not exactly what I thought it is, but I really like mechanical. It's very easy for students to move around. They don't have to leave engineering. So the experience is that the students take a lot of electives and a lot of the math and sciences class in the freshman year, but they have this introduction and they're welcome to the department. They start interacting with the students through our large number of clubs, student activities with American Society of Civil Engineers, and other activities that you have. So the students, they are engaged to the department. Many start doing research even their freshman year, and start looking what the cool things in the department. But again, the classes are set in a way that it's very easy for them to move around. And I think that Paul can talk about this in a better way with the bigger perspective from the engineering as a whole.
Yeah, absolutely. And if for those of you in the audience that haven't joined the Viterbi School-wide virtual information sessions, we held one yesterday. We're going to have another one on next Tuesday. We run them on Tuesdays, and so we'll follow up with you in case you haven't seen that. That's where we'll talk a lot about the ideas of flexibility and overall curriculum guides. But for today's talk, we're going to really focus on civil and environmental engineering. But thank you, Lucio. I appreciate that. Anything to add on that, Amy, related to environmental engineering? And also, I would actually want to add a question as to tag onto that, which is, what is the difference between civil and environmental engineering? I mean, it sounds like a simple question, but sometimes students are kind of on that border, and we do have civil with an environmental emphasis, and we do have environmental engineering. So if you wouldn't mind.
Okay, so first I'll say the whole department just underwent a major curriculum revision. And so our curriculum in both programs, civil and environmental, has been updated. I'd say it's as updated as you can get, and it's highly relevant curriculum. All of the faculty joined together, and everybody's been involved in making sure that classes connect to each other and that students are getting enough breadth and depth in certain areas. So how does environmental differ, or how similar is it to civil? Uh, Environmental is interdisciplinary in the sense that it touches on civil, it touches on chemical, and at times it touches on mechanical engineering. In terms of how it relates to civil major infrastructure issues, water treatment plants, wastewater treatment plants, those are our civil infrastructure. But then we also get into more of the sciences. We focus a little bit more on chemistry, a little bit more on biology than the civil engineers. And so that's where we connect more maybe with chemical engineering in some of those ways. So, but you can join the department and for the first year take the first year of classes is very similar for both programs. So if you join as a civil but want to focus on environmental, it's easy to move early in the beginning. And as Paul mentioned, you can be a civil student focusing on environmental, or you can go fully the environmental track. And I'd say the difference there is what I was talking about with, if you want that more infrastructure kind of civil feel of environmental, then the civil environmental route is the way to go. But if you like the sciences more and want a little bit more of a basis in chemistry and biology, and maybe a little organic chemistry, then the pure environmental route might be better for you.
My answer to high school students is that you remember the classes that you have about velocity, acceleration. Civil engineering, it's very based on that. The difference is that buildings should not have velocity, neither acceleration. If your building starts accelerating, you are in trouble. But again, the equations are very similar. So I would say that the civil, it's much more physics basic, and the environmental has to go much more to the chemistry, about understanding about water contamination and those things. It's much more in the chemical. But again, there is overlaps because what Felipe was telling, he has a lot of physics understanding about how velocity in the water, everything in the subsurface water. So there are interfaces that they cross, and they are very healthy interfaces. And this is why you are a department. You are not two departments, because we do work very, very well together.
Yeah, the intersection of the two areas is important. I'm going to give all of our guests kind of a 2-minute warning here for them to start thinking about their questions, as I'll open it up for questions from them in just a moment. But before we do that, I think what might be interesting is these students are coming out of high school and trying to decide which university they're going to attend, and they have a lot of great options for them. And sometimes they think this is the beginning or the end of their successful career based on whatever school they attend. But I know you all have different and unique academic backgrounds. Would you mind sharing individually kind of where you went through your schooling and how you ended up at USC? And then we'll go to the questions. Felipe, why don't we start with you? And then we'll work our way backwards. We'll go Felipe, then Amy, and then Lucia.
Sure, very well. So I'm a mechanical engineer as an undergrad. So my bachelor's in mechanical engineering, as well as my master's in mechanical engineering. I did my undergrad in Brazil, in Rio de Janeiro, the city where I come from. But it was all in mechanical aerospace and mechanical engineering. Then I got my master's in mechanical engineering with a focus on turbulence, numerical methods, fluid mechanics. Eventually, later on, I moved to my PhD at UC Berkeley, where I got my doctor's degree, and that's where I got my degrees in civil and environmental engineering. So I have actually 3 degrees, actually, if you think about it: civil, environmental, plus mechanical as well. After that, I did my first year postdoc, for a year and a half postdoc in Germany, in Stuttgart. And afterwards, I did almost 3 years as a research fellow in Spain, in Barcelona. That's I lived for there for about 3 years. And then I was lucky to get a job offer, or they were crazy enough to offer me a job at USC, and that's where I am now for the last 7 years. That's my background.
Right. So we got Rio, Stuttgart, Barcelona, and Los Angeles. It feels like my vacation.
Too.
Yeah,
Berkeley.
Yeah.
Oh, you got Berkeley there too. Yeah, you got Berkeley there.
That's just a few of the cities. I mean, I lived in other places too, but it just but that's exactly.
Great,
Sure.
thank you. Amy.
So I was an undergrad at the University of Maryland, and I was in the civil engineering program. And it was about the time when environmental engineering programs were just starting to come to fruition. And so there weren't a lot of them. But I went to a professor who taught water processes and said that I wanted to study environmental engineering. And he said, go to California. And I had never been to California, so hey, that's how I'm here. No, so I did go to UCLA for my master's and PhD, and began studying membrane processes at that time. And now, of course, I'm at USC, and it's a good place. You don't always get to study a topic that's so appropriate for where you live, but living in an arid region that's often looking for new water sources, it's good to be in Southern California.
Thank you.
About me, okay, Korea. It's curious, but I am originally from Brazil too. So me and Felipe, I got my undergrad at Federal University of Rio Grande do Sul. It's a capital of a state in southern Brazil, Porto Alegre. In civil engineering, I got my master's in construction management at the same university. I had a construction company for around 10 years and had the feeling that construction was dirty, dangerous, behind schedule, over budget, and I didn't have the right tools to fix it. So I decided to walk away from business and come back to academia. Came to the US, to MIT to get my PhD. Obviously, at MIT, no one had any interest in construction. I don't think that my professors ever saw a brick in their lives. They are all very theoretical, and coming from industry for me was pretty fun. I ended up doing my PhD in the interface, and I got my first professor job as a professor at the University of Illinois, Urbana-Champaign, where I tried to merge my experience in the real world with the computer science and civil engineering. And it was basically a new focus within civil engineering, not very common at the time. So I was very lucky to be at the movement applying those things to civil engineering. Then I moved to be a professor at Carnegie Mellon in Pittsburgh. And around 8 to 9 years ago, the dean was wanted to rethink the civil environmental engineering here at USC. And he came and offered me the chairmanship to implement changes and put a lot of resources behind. So you are capable of hiring a lot of people. Amy was hired, Felipe was hired, and around 10 people beyond them. So it's a new department, as I said before, with a new focus and very, very interesting people. Very fun place to be.
This is great. Thank you so much, y'all. And just as it points out, that you all pointed out a number of different institutions that these students in this room have been admitted to, and they're debating between. So that might be something to think about as we're getting to questions. So for all of our students that are in the room, let's start firing away your questions. Throw them into the chat. I'll do my best to distill them. I'll do our best to get to as many as possible, and I'll kind of moderate the questions and give them to our panelists across the board. Let's see what we have. Okay, so the first question from Nicholas about Calc 2 first semester. I think you're reading it wrong, Nicholas. Everything starts with Calc 1 in the first semester. But when you have calculus in your background already, based on either AP scores, anything else that's an equivalent to our score, we will move you up in the sequence as necessary. So if you've done work that's proven as an equivalent to our calculus courses, we're going to adjust you all the way up. So with a 5 on BC, then that will count towards Calc 2, and you can start in Calc 3 if you're ready to do that. So we will place you appropriately. You don't need to repeat things if you've taken a course that is an equivalent to us. So I think that's what you're asking. Paul asks about, can you demystify some misconceptions about civil and environmental engineering? I'm going to guess on the misconceptions, but I'll let you guys fill it in. One of the misconceptions that I hear of a lot is that, well, civil engineering is just old engineering. It's not new. It's not high tech. And I know that that's definitely not right. So I'd like you guys to talk about that, or maybe add on to that the idea of what is infrastructure and what are we needing at this point, especially when it relates to our current situation and in environmental engineering and the things that we need to advance as far as across all disciplines or all types of industry that's out there. It's a convoluted question, but they talk about misconceptions. So what can you help our students understand?
So you want me to talk about that? Yes, I don't know what he meant by misconceptions. Yes, but I do agree that people really think that civil engineering is from late 1800s, early 1900s, building bridges, and it still is. But it's still you can think about bridges today that are smart, that have sensors and ask for help before they collapse. So say, hey, I have a problem here. Close me, don't let trucks drive on top. So all those things are evolving, and the bridges didn't stay to be the bridges that were in early 1900s. There are a lot of cool things happening. For example, as I said, I work in the interface of computer science and civil engineering. I just finished a project to the Army where you are, the Army is flying drones and you are creating 3D models of war zones and allowing the soldiers to kind of in a game interface, put snipers in buildings and try to see what the snipers can see, what are their angle of view to move the soldiers hiding behind buildings, not be seen by the snipers. So we have all those interesting things going, a lot of interaction with smart elements and sensors and artificial intelligence and all those things are happening in the world, happens in everything, happens in smart buildings, in smart water systems. So again, civil engineering didn't stop it in 1900s, even if it was doing a lot of interesting 1900s, and a lot of the things that were done in early 1900s are still there. Thank God, those bridges are still there, and you're very proud that they're still standing. And you see them and look at them and say, "Oh my God, this is real." I'm very proud to be part of that movement that built those bridges that are not in trashes like the processors that were built 15 years ago, 10 years ago. So we build things to last, but you are building them, adding the new technologies and evolving. Anything to add, Philippe and Amy?
Yeah, actually, yes, quite a bit, actually. I mean, from a point of view, even of materials, right? When we think about novel materials for construction or structures, we have a faculty in our group which actually develops mechanics of new materials. In other words, materials that react to sunlight, materials that react to electromagnetic pulses to obtain the desired outcome, for example, in the design outcome. We have very exciting things, even in the hydrological aspects. When we think about tsunamis and hazards, right, related to tsunamis, this is civil engineering. And like I agree with what Professor Soiberman said. I mean, we talk about bridges and buildings in the early 1900s, but we should be very, very proud of that because, I mean, they're still there, right? And putting up a bridge is not that easy. It's trust me, it's very, very complicated. So we tend to, only look at the final product, but there are a lot of technological innovations that go along with it. So there is a big shift, as Dr. Soiberman said, about bringing AI, artificial intelligence, in civil engineering, but also in hydraulic systems, environmental engineering as well. A lot of exciting things happening. A lot of exciting things. Professor Childress, maybe you want to add something.
Sure, yeah. So one thing that comes to my mind is, and I'm going to go back to the bridges and buildings that we drive across or walk into, and we feel comfortable that they're safe. And the reason we feel comfortable is because a civil engineer, a professional civil engineer, has taken a stamp and stamped that this project can go forward, that it's safe, that it makes sense, and that it was engineered. And that's what makes, I think, civil engineers unique from other engineering. A couple of things. One, the scale of the project. It's very tangible, and it requires that stamp. And not all engineers can get a stamp, but it's typically the civil engineers that need that stamp. And so as the public, we might take it for granted that we build bridges that won't fall, or buildings, or infrastructure that'll stay in place, but it's that one civil engineer stamp that guarantees it. Also, the system concept, I don't think so many other engineering program or outside of civil engineering systems aren't talked about so much. So it's this larger scale. A lot of times the other areas of engineering focus on a much smaller scale, something under the microscope or a material, whereas civil engineers look at the scale of a city, for example. And I think civil engineers interface more with society than other engineers. You can't build a project or put up a bridge or do things for society unless you're willing to interact and interface with them. And that's a skill that we hope we help you develop in our program.
Great, thank you. There are a few questions here. One I'll answer real quick, and then I'll get back to questions for you all. Is it possible to double major in engineering and a different discipline? Yes, it's always possible to do that, but just as a heads up, when you add a second degree on top of your engineering degree, you are adding time. And so if you're thinking of a second degree on top of either civil or environmental engineering, you are likely looking at least 5 years, but we'll advise you on that process. And just so you know, nothing will affect your first semester at USC. So we want to get you started in the engineering curriculum, get your feet under yourself, find out whether it's right for you, and actually, so that we talked about that earlier with Dr. Sobelman, this idea of flexibility. We want to make sure you're in the right discipline, and if you want to add more work, you definitely can, and we'll help you with that process. So that is possible to do that. And also
one thing that I'm seeing is that many of those students are being able to do double major within 4 years because they are coming so many IP classes. Those kids are so amazing that they are arriving, that they are being able to transfer a large number of classes, and in that they can do the double major and still graduate in 4 years. But really depends in each student what they bring. There are students that I don't know when they sleep. Okay. I don't know. I look at them and say I don't even want to know how you do that. But everything is possible. It's really each student has to customize for their ability, for their working ethics, and for their background. And this is the good of being a smaller school, that you can listen and can evaluate and can give the right feedback for every specific student.
Wholeheartedly agree, and that's exactly what I was about to say. Let's get you started and see what you want to do. Some students do it in 4, but I want to manage the expectations appropriately. Plan on that being a 5-year program for the time being, and we'll work back on that. There's versions of this question, so I'm going to kind of consolidate it down to: can we talk about internship opportunities? Can we talk about jobs? Can we talk about the companies? And I'll fill in any gaps on the back end.
So I would like, because I saw another question that was related. Are all professors researchers, or there are professors that are very just concerned with the success of students? We're all concerned with the success of students. Okay?
I was going to say, I was going to that question next.
This is a priority. Okay, so. But again, we do have students, faculty that are just work with the students. So we have those called teaching faculty, and we have at least one in each of the main areas that brings the connection to industry. This is why I'm connecting this question to the previous one. We have a teaching faculty in transportation, a teaching faculty in construction, a teaching faculty in structures. They all came from industry, and they all can really mentor, and their whole dedication, it's not to the research, but the bridge with industry. We do use a lot of teaching faculty too, or part-timers to teach the design courses, and they do come from industry. So we do have a very good relationship with the industry, and this is what you expect because we can. Okay, we are in LA. We have the most active and probably the biggest construction industry in the country, 1 mile from campus. Okay, they are all big corporations in downtown LA, down the street. So talking about other universities, this cannot happen in the majority of the public schools in engineering that are in small towns like Champaign, Illinois, West Lafayette, because the industry is not around. So this connects to the idea of internships, jobs. Everything's very connected to the fact that you are in a mega city like LA, that a lot of things are happening. Those companies are hiring, they are building relationships with the university, they are either teaching some classes as part-timers, they have very good relationship with our masters, that's more technical. So we use a lot of industry to help us teaching the master's programs, but some of those classes are taken for upper classes undergrad students. And at the same time, they are mentoring our students in competitions like the CMAA, Construction Management Association of America. We have a national competition that we send 8 teams every year. So have 8 industry mentors that comes and train and teach our students and prepare our students for those competitions. So this is the big advantage of being next door to downtown LA. We have those resources and you use them extremely well. Obviously, that the question now with COVID-19 and everything, we really don't know how until now, all our students had 2-3 offers and for jobs. We had difficulties of convincing our students even stay for masters because all the undergrads are getting jobs. I don't know how this crisis is going to unfold and how this is going to change, but still you are in a better shape than the rest of the country.
Yeah, definitely. And I think that something I would want to add is that in the Viterbi School overall, we have our own career connections, our own career staff, our own career services working specifically with undergraduate engineering students to help you with those opportunities with internships and full-time positions after graduation. And we bring hundreds and hundreds of employers onto campus looking for all majors and engaging not only with just individual career counseling that we do, but also those career events like career fairs, some new virtual types of events, some new meet and greets, networking opportunities. When students are engaged, they have lots of opportunities. And so we're very clear on helping students with that. In the question I wanted to get to, and I'm glad, Dr. Soibel, you brought this up, this idea of are there professors that do all professors have research projects, or are some solely dedicated to undergraduate success? And I think in reading between the lines there, I think what's going on is comparison to other universities, where sometimes the stereotype is that faculty are there to serve graduate students and undergrads just work with TAs. And can we talk about the differences of USC with some of the other institutions you've all been at and how you are engaged with undergrads?
I've been talking a lot. I let Amy go this time.
Yeah.
I can speak from, so I'm not teaching an undergraduate course this semester, but I can tell you my colleagues love their undergraduate courses. So in environmental engineering, all of our courses are taught by our faculty, except our design course, which is taught by an outside PE. And that's good because he brings internship possibilities and job possibilities and a connection with the real world. But other than that, our professors teach the undergrad courses and they like teaching the undergrad courses, truly. And I think I would consider the program to be somewhat boutique. It's small, so it's not really large classes where the instructors are overwhelmed by the number of students. It's small classes. We know everybody in the classes, and we want to see them leave our program and either get a job locally or elsewhere, or go on to graduate school. And our faculty stay involved with students who want to go on to graduate school and make sure they get applications in and work that way. And the same with jobs. So one person asked if freshmen can get summer jobs. That could be a little bit harder, but I would say kind of sophomore on, once you've got a little bit of engineering courses under your belt, then yes, our students get jobs in the summer and they get jobs when they graduate.
One thing important that I would like to add is that TAs are not allowed to teach at USC. Okay? So the classes are all taught by professors. TAs, they do the office hours to help students do the homework, and they do the grading. They work with the students. They help with the assignments, but they are not teachers. They are not allowed to teach. The only interaction that students have with TAs are in the labs, because in the labs you have, for example, if you have 30 students in a class, we divide in 3 sections of 10 students in the labs, because labs you really need hands-on, and each student needs to have a station. And again, then we have the TAs together to make sure that the students will not hurt themselves. They will follow the process well. So this is the classes that the students interact more with TAs, are the lab classes. There are some tutorials that you add that is outside classroom time, that when you realize that the students are struggling with a computing software or something, you add some tutorials, and then we ask the TAs to help with that. But all the classes are taught by professors.
Thank you for clarifying. Nicholas, you've asked these questions about the calc requirement. I see what you're referring to. Trust me, Calculus 1 can fit in there. You can start in Calculus 1 if that's where you're placed appropriately. We move a math sequence down. We can move a general education course to spring semester senior year, and everything still fits inside the 4 years. And that's, of course, not even counting any other AP or IB credit. So it all fits. It all is there for you. It's all ready to go. Now, Pooja was asking this earlier, and I think this is a good opportunity to talk about it. Can we talk a bit about building science? What is the building science emphasis? What is the balance between art design courses and engineering courses? Can you give us a little bit of background on what building science is?
Building science, and I saw someone ask the difference from structural engineering to building science. There was a question that was
Great, yeah.
Structural engineering, it's civil engineering, taught in civil engineering, and with focuses on mechanics, materials, and structures. Building science, it's an hybrid that the students take. They are civil engineering students, but they take classes in architecture. So they take 6 studios in architecture. So they take 1 per semester in the last 3 years. So they just don't take in the freshman year, but everything else, every semester after the freshman year, they have those studios that are the way that architects teach, is that it's very different than engineers. You're really hands-on, you're doing design, you are working. The director of the program is in the civil engineering department, it's David Gerber. So he's a part of the department, but again, he teaches the classes in architecture too. He's an architect. And then the students have some extra class like history of architecture and those things. So it's an hybrid that the students are learning, taking the structural engineering courses, taking the classes that civil engineering students take, and then they take those architecture class. Makes a very hireable professional. There are not a lot of universities that produces those types of professionals, and companies really love to have this type of professional that really, even in the construction site, because they understand better what they are building, or even to work later more in the architectural side, because they understand the consequence, the cost, and the structural consequence of their architectural decisions. So it's a very unique professional that can get jobs in both directions after that. But it's very different. There are the whole set, and there are more units. The students take more units to graduate.
Great, thank you. Are there the questions about software, but I'm going to actually broaden this question. Is there anything that you would recommend to incoming civil and environmental engineering students to prepare before they start taking courses with you this coming fall?
I can answer, but
I'm very personal. have a personal response to this, but I'll let you
I
guys
say
go
have
first.
fun in life because
Thank you.
because you
It's
are
mine
coming
too.
to work very, very hard. Don't work hard before you come here. Okay?
Enjoy
life
life
a
now.
little bit because you are going to get you working very, very hard. Anything to add?
We get this question. We get this question all the time, and my answer is always the same. Like, we have so much work waiting for you. Use this as your last opportunity to have no work. Trust me, we're gonna get you going. You're gonna be fine. It is your last summer before you have obligations. So, but my personal rating is have fun, but also maybe go get a job if you can. I mean, this current situation is a little bit hard, but if something just to earn some money, to have some stuff to play around with, that would be good as well.
Anything to add?
No, I agree.
For me, just fun. I agree totally with this. Enjoy.
Yeah, great, thank you. What advice do you have for incoming students as they approach your curriculum, as they approach the discipline, or as they approach just going to college in general?
I can speak to that. I experience a lot of students who come in and they have their full class list, and then they want to do extracurricular and they want to work in a lab, and they quickly get overloaded. And the way I see it, they end up not coming to work in the lab, which is fine because I realize they're not going to have time for it. And then they're trying to spread themselves between classes and extracurriculars. And I just would say maybe do less and enjoy it more and focus on a few things more.
Yeah.
You'll have time to do all the things you want to do, but come in and pace yourself. And maybe that would prevent some burnout that could happen.
And I would talk a little bit about the issue that I said that was an advantage before. The fact that the first year, it's very similar for all the students in the whole engineering school. So what I'm trying to say is that you are going to have a little bit more distance from the department in the first year. You're going to be taking one class, interacting with one student, with one faculty or two. I would strongly recommend you to come and visit us, okay? Come to the civil engineering department, come to the environmental engineering department, attend our parties, our events, our things. Try to be part of the department as early as possible, because you are going to start meeting the faculty, finding out the ones that do research, what research they do, get to know their labs. I think that early that you do this is better. Early that you start participating at our teams, the competition, CMAA, structural engineering, earthquake engineering team, or the environmental engineering team, ASCE, and other things. So more you start building relationship with juniors, sophomores, and seniors. They can mentor too, not just professors. So try to engage yourself to the department as early as possible.
Felipe, anything else? It's a lot of good advice.
Well, if I can give one advice that normally people overlook in the engineering education, you have a few calculus courses you have to take, chemistry, physics. Study those well. They're not just prerequisites for engineering classes, but they can be very, very useful later on. So take those courses very, very seriously, especially the math classes, and in physics and chemistry as well, because you're going to be using a lot of that actually. And also coding, especially when you have the coding classes too. I mean, learn that well because it's going to be very, very useful.
Okay, great, thank you.
But I do agree with one thing, if I may emphasize one thing that Professor Childress said. I mean, sometimes less is more, right? Focus on what you really have and study, don't do too much, take your time to learn things.
Yeah. I would double down on that, in that there's always two sides of that coin. I think that when we admit highly successful academic students that have been successful outside of academics, they always know how to go at like at an 11, right? And then they come to USC and they think they're supposed to crank it up to 12 or 13. And I always tell them, like, you'll get there. Just let's start a little slow. but you don't want to turn it down to a 0 either, right? We get so many students that are scared to do anything, that they're just, I'm here focused on my academics. And we find that students that don't even get involved at all have struggles as well. So there's a balance, right? It's finding that right balance between things. And that's the hard part about your first year, is that you're going to overstep, and you kind of have to overstep a little bit, but don't go too far to understand where your limits are. And it's all about the time management process.
Other thing that happens too is that you are all the best students in your high school. Okay? The students admitted here are all top students for their high school. So they are always the outlier, and here they are going to be average. So you have to learn that you are not the one, and learn how to live with being the average, because all your classmates are going to be outstanding. So and it's good at that level. It's good to be average. So so there is a little bit of frustration that some students think that they have to be the best in class. It's not that easy here as was in high school. So you have to learn here to work much more with your colleagues, not against them.
Absolutely. Jessica, you asked a question regarding some, I think it might just be a misunderstanding. Email me offline, and I'm happy to look at that with you. But I think it's saying the same thing. It just may just be a switch in terms. So I'll help you understand that a little bit more, Jessica. Pooja asked a question related to fall. We got this question yesterday. We're in an unknown time. We don't know what the future holds for us. And the question is all about fall and this summer. First off, this summer, all of our new student orientations, they happen usually in June and July. All of those have all been moved to online virtual sessions. And so the orientation programs, meeting with your advisor, scheduling your first set of classes, that'll all happen virtually. And those are all being planned and set up right now. So that's where summer's going to go. For the fall, everything's planning as if we will be back on campus, and life is normal. If it's not, I'm assuming the university will make an announcement when that decision is made. And this semester, everybody pivoted rather quickly to a robust remote learning environment. And I'm assuming something similar like that would happen, but I can't make any predictions. USC has been very good about being transparent and quick with their decisions when they need to. So I'm confident that decisions will go out when necessary. Okay, let's see. Is there anything else? When you think of your most successful students at USC that are graduating this year, do they share any common traits? It's an unfair question, because I know there really isn't an answer to that question, but what do you think about when you think of some of your most successful students?
Well, if I may, I have one, I'm teaching an environmental engineering class on contaminant transport in the environment, ENE 300. And I have one student in that class that stands out. I mean, she's doing a superb job in every possible way. But I think one characteristic that I noticed, especially in the other undergrad classes that I taught, proactiveness. Students which are very proactive in taking the time to study, asking questions, but they're not just waiting for things to fall in their laps. Actually, they're actually moving forward and trying to seek answers. They're going beyond. They're walking the extra mile. All right.
I like that.
That's one. I think that's at least what I noticed. Maybe Professor Childress and Professor Soberman have other comments to add.
I'm going to say persistence. So students who, through challenging times or through really hectic times that they have, maybe multiple exams in a week, they persist. They communicate with the professor. I've got all this going on. Can I turn this in later? So so persistence and a lot of communication and a willingness to talk to their professor, to realize that exceptions can be made, that things can be figured out during hectic times, but not just to let things drop.
I would add to that passion. So persistence.
Three P's.
The three P's.
Okay, I would add passion because the students that I really see, the ones that succeed, during the time that they are here, they develop passion to what they do. The example that I was really shocked, there was a student, she's an environmental engineering student. She was the captain of the soccer team at USC that was national champ when she was playing at the team. and still one of our top students. And she got hurt and had to had several knee surgeries and had to retire to the soccer career. And I was very concerned with her, and I met her and I said, "Oh, what's your plan? What you're doing?" So I thought that she was going to complain, and she looked at me with a big smile and said, "No problem. I'm doing what I love. I'm the happiest person in the world. I don't care about soccer. I really, really love environmental engineering, and I'm going to change the world. What I'm learning from those amazing faculty, it's the capability of making the world a much better place. What else do I want in life?" So I was embarrassed that I, I said, I asked the wrong question. So I was almost crying when I left. I said, "Okay, she taught me a big lesson. Okay, don't go to the students and ask those types of questions more." so, but again, and I see this kind of passion, what they building that passion. It's the most amazing thing that I see in our students.
Well, we're gonna wrap this up, but I want to have one more question for each of you. If you might want to be able to chime in. You know, our students, they're fantastic. We've talked about that a few times. Hopefully, it doesn't go too much to their head. I'm sure you'll fix it when you get them into your class and give them some work. But when they're thinking about where to go, they have the top engineering programs out there that they've been accepted to. Great universities, lots of options. They can't make a wrong choice. But if you wouldn't mind, why should they come join USC in the civil and environmental engineering department? Whoever would like to go first. I don't want to put anybody on the spot.
Amy.
Everybody put Amy. Hey.
Well, I feel like I'm going to repeat a few things that I already said, but our undergrad program is smaller. Our professors teach our courses. There's a lot of interaction. Our professors like teaching our courses. I think we get energy from undergraduate students, and the last time I taught an undergraduate course, which was less than a year ago, but it opens my mind. It makes me think about things differently when I see what the current generation of undergrads is worried about or where their emphasis is. And I think I'm not alone. I think all of our faculty like that engagement, and I think USC is unique that way. I do want to say, one person asked if we have ASCE. We do have ASCE. We also have Engineers Without Borders. Dan McCurry, who's in the CEE department, is the faculty advisor for Engineers Without Borders. They took a trip last year to Central America. They were supposed to take another trip next month that got canceled, but we have students and faculty engaged in several student organizations.
If I may add something to Professor Childress, I believe maybe the cherry on top of the cake for Dr. Soiberman. But I think we have a very unique group here in Civil Environmental Engineering at USC. We have outstanding energy, not only from the senior faculty, but we have a lot of young faculty who are very, very engaged teaching and passing on knowledge. We are doing things which are very, very unique. We have a professor in civil engineering, Professor Burchan Bicharik, where she's doing unique classes on the refugee crisis in Europe, where she takes students, maybe Dr. Soiberman can add more information on that, to Greece, and to provide civil and environmental engineering solutions in refugee camps. I have not seen that in any other course or in any other engineering department or any other university. We have students taking classes in environmental engineering with Professor Adam Smith, McCurry, Kelly Sanders, Ben Wise, hopefully me too. I mean, in the sense, where we actually are very, very engaged in teaching. I mean, the best classes I taught in my years at USC have been undergraduate classes. So there's a very good vibe, a very good energy. And needless to say too, I'm not saying this just because he's here, but we have a very proactive department chair who is very concerned in hearing the voices in our department, of students, but also faculty as well. So it's a very unique place. The thing I love most about USC it's not USC itself, but all the colleagues I work with. I have outstanding colleagues
And
because I see the level of engagement.
And
Sorry,
I would thank you, Felipe. And I would add to what I said before. It's very uncommon for a top 10 school of engineering to be in a big city. Okay, it's very common to state universities to be in land grant institutions in the middle of nowhere. So the fact that you are in a big city that is so the center, LA, it's a center today. Even the center of gravity from the Silicon Valley, it's moving to Silicon Beach. You have TikTok, it's in LA. Snapchat, it's in LA. So the new things that are happening in this area. And at the same time, the level of construction demand in Southern California is absurdly high. So this is civil engineering. So all the large engineering corporations, they have offices in LA, or they are from LA, AECOM and Tutor Perini and all those, and they are very connected to the university. So this makes a very unique experience for the students to be in a place that at the same time they have an amazing faculty in almost like as Amy said before, in a boutique environment where they are having a lot of hands-on experience and learning in a very active mode, but at the same time that they are so near the change, the center of gravity of the nation in cool things that are happening today.
Just adding a piece of information here as well, just to provide evidence from a point of view, from my perspective. Not so long ago, I'll say not even recently as well, I try to, when I'm teaching my classes, I try to connect with what other faculty are doing. I'm very much in the interface between environmental engineering, water resources engineering, civil engineering. So I have the privilege of working with two groups of students in the same department. But very often, when I mention my colleagues' work, when I try to connect what I'm doing or what I'm teaching with the work that other people are doing in the department, their eyes shine. For example, I think at least 3 or 4 times I remember mentioning Professor Childress' work, and the students, they just, you can see they smile automatically, when they think about what she does or what she represents to them in terms of leadership, right? When I talk about Professor Bicharek's work in Greece as well, or even Professor Ciota's work, and air pollution, Ben Wise and other people, there is a sense of joy I get. You can see the eyes of the windows to the soul. That's what they say. I can kind of see that actually. Sorry for being a little bit over poetic here, but that's I think it's something beautiful to see, right? And then that's again this sense of enjoyment, of joy, when they talk about their mentors or their professors, that tells me that things are working really well here.
And can I add one thing real fast? As Lucio mentioned, we're in a very large city of Los Angeles. There's lots of major engineering firms, and we have alumni at all of them. I won't even say most of them, at all of them. So USC is amazingly well connected. I continue to be amazed by that. So, and that, again, it is good in terms of internships, jobs, and those sort of connections.
I'm going to put a bow on this with something that was said earlier today. Proactive, persistent, and passionate. Those 3 Ps is not only great advice from our faculty, but I think the best way to describe these faculty. And the best way to describe the environment that you will find yourself in when you come to USC. And nothing reflects that better than this conversation. And so thank you, Dr. Childress. Thank you, Dr. Soibelman. Thank you, Dr. De Barros. This idea of talking to our students, engaging with them, showing them who you are. I can vouch for it, everyone. These are incredibly fun people, not to mention incredibly brilliant people. Dr. Soibelman mentioned going to the parties and the get-together. I don't get invited to those, and I wish I did, because they have great ones. I've heard about them for years. I've asked Dr. Soibelman multiple times, and I'm now asking him on record with people here to get an invite at least once, but I don't get it. And in the sense of community,
you can be the host for our ski trip next year.
See, that's what I'm talking about. The ski trip. That's the one I'm talking about. I keep getting upset about this. Anyway, he took me off my notes. But there's obviously a strong sense of community at USC. There's a strong sense of community in the Viterbi School of Engineering, and there's even a stronger core inside this department with faculty and students that care, that want to make a difference, not only in solving some of the world's most complex problems, but just being there for each other. And that's something that I don't know of that exists anywhere else. And, I can do admission in a lot of places. I can work in a lot of schools. I don't have to work in an engineering school. This is the reason I work here. This is the reason I like doing this and why I've been here for so long. It's for people like this. And the students that I've all met, a good number of you, when you come in here, you're going to just fit in quite nicely. So I wish you the best of luck with your decision. You have until May 1st. I know that's a rough deadline. I don't envy that position. We'd love to hear from you no later than May 1st. You do that at your portal, admission.usc.edu/status. More information is available at viterbiadmission.usc.edu. We have other live chats going on this Friday. We're going to have an alumni live chat where you can join into. And if you haven't sat in on our Viterbi keynotes, they happen on Tuesdays. All of that's on viterbiadmission.usc.edu/admit. So I'd love to keep the faculty on, but when I end the meeting, you're all going to go away. So I'm sorry for that. But,
so just one thing, I just typed in my cellular phone. If any of you want to call me, feel free to call me. I will be here. I'm stuck at home. I have nothing else to do but talk to you guys.
So you can see that in the chat, everybody. He just put his cell phone into the chat. I'm not going to repeat it because we're going to put this out on our podcast. I'm not going to put it publicly.
You can put it, no problem.
I'm not going to do that. And then if you need more information from us, our phone number, we have a remote number that we're all answering. It's 213-600-9919. And so anything that comes up as you're making a decision, let us know. Best of luck to you, everybody. Congratulations again on your admission. We hope to see you in the fall at USC, and fight on.
Bye. Bye. Thank you.